Hello, everyone. Welcome to the workshop with Optimism. This is Annie from Optimism over here. I hope you're all excited. We're really excited and so happy to have you here. While we wait for everyone to filter through, I just want you to pop into the chat box how you're feeling about submissions on Sunday on a scale of 1 to 10. Do you feel confident to submit 10? Do you feel like you're time pressured? 1. I'd love to see the answers, and I hope you're all doing well. I've seen some great projects so far. There's awesome ideas and really excited to see the final submissions. So the previous workshop we had with Optimism was an intro into Optimism. Annie over here is going to give us a slight deeper dive into how optimistic rollups work today. And I hope you're all really excited. Annie, I'm going to hand over to you and let you introduce yourself to the cohort.
Cool. Hi, everyone. I'm Annie. I work at Optimism. I've been there for a while, since February of last year. Joined when we were very, very small as a backend engineer, and these days I work on protocol partnerships, so kind of the technical collaborations with the ecosystem. And I think this workshop is really geared towards a deeper understanding of how rollups work, and really a chance to ask all of your questions that you think are stupid, but really are like very crucial questions. So I'm excited to do this deep dive today.
Awesome. Thank you so much, Annie. So everyone, as you'll know, we've got 10 more days left of hacking until the final submission date. So it is crunch time. This is an awesome workshop to have. As Annie said, if you've got any questions, please do feel free to ask. We can leave time for some questions at the end, but if Annie pauses in between and wants to take questions, she will do during that time. Annie, I'm going to hand over to you and you can begin the presentation.
So today's session, I'm going to be doing, as I said, a deep dive, like instead of a 101, a 102.0 on how optimistic rollups work. And from my experience, kind of what has been confusing to people in the past are really these two areas, topics, like rollups and decentralization, and like why the industry seems to trust rollups more in terms of them being a decentralized and trustless solution, and how does that really happen? Like, how is it secure? The main thing that I will talk about is kind of this mechanism called the fault proof, which lies at the heart of how a rollup works, and also this entity called the sequencer, which is how rollups produce blocks. And the second thing that I've seen a lot of people, I think, more confused about is around rollups and Ethereum, because I've gotten questions that have passed on, oh, what does it mean if there's rollups and ETH2? Is ETH2 going to eat rollups up? So I will talk a little about this too. Let's get into it. And I have open chat, so if you have chat questions, let me know in there too. So rollups and decentralization. When I first started looking into the L2 space, so a little bit of background: before I was at Optimism, I worked at Coinbase on their protocol team. So we integrated a bunch of blockchains, and I was in kind of the multi-chain world, interacted with Ethereum and Bitcoin, but also like the new things coming out like Polkadot and such. And that was also when bridges were starting to happen. So when I first started working at Optimism, I really actually the first time I talked to them, I had no idea what a rollup was. There's like chains that are a bridge to Ethereum. I was like, how is that different from a rollup? Then there's also like people talking about like ZK rollups, and then there Optimism currently is an optimistic rollup. So really, what's the difference there? So let's dive in a little more. But I'd say the main difference between rollups and sidechains is how the rollup secures itself to the main chain. And the main difference between the types of rollups, where it's ZK and optimistic, is really how this security mechanism works and when it works. So let's dive in. Cool. So the main thing about an optimistic rollup is that you don't go to court to cash a check. So you don't check this every time, but you go to the court if the check bounces. So what does that mean? It means that in an optimistic rollup, block production happens optimistically and gets posted to L1 Ethereum. So everything happens on the rollup as if it is functional. But if there ever is dysfunction, then we go back to L1 Ethereum as our court to kind of mediate to what should have happened. Whereas, as a comparison, a ZK rollup is constantly checking, whether whether transactions are valid. They're constantly checking against L1 on whether what's happening on the chain is what's supposed to happen. And a side chain doesn't really have this court system. So, if that makes sense. Cool. So for everyone who has maybe built on Optimism or built on Ethereum, you'll know that L1 Ethereum and L2, even though Optimism and EVM-equivalent, there are different states. Like, for example, you do have to bridge your ETH to be able to use your ETH on Optimism and such. So there is kind of like a state on Ethereum, and it's different from state on the rollup concept. And this is what I'm trying to illustrate here, that L1 Ethereum, they have their blocks, and L2 Ethereum, you're producing blocks too, but here I'm trying to represent like state. So a state is just like how much ETH, how many tokens, like an account holds, just general chain state with all of the accounts. So we start off with L1 Ethereum producing blocks with L2, it's kind of separate. And as more blocks are being produced and as L2 experiences state transitions, so state transition is whenever the state changes, and state changes through transactions. Like you say, send your friends some tokens, that changes state. And when you, do like different actions on the blockchain, as y'all know, that those we call state changes in like kind of a more like deep like researchy world. But yeah, let's look at the state transition. And what Optimism does in the background is we actually roll up these transactions. We put a lot of them together and chunk them all into one. So this is why L2 save costs, is that we are only really incurring L1 costs every time we roll these transactions up, which is why we can scale cheaply. So once these transactions happen, they're submitted back into L1 into these blocks as transactions, so that there is a record on L1 of how what is going on L2. So when a transaction happens, we denote that as notarized. And when so a notarized transaction is one that's been rolled up, and then a proposed state. So what happens when we submit is we submit a bunch of transactions and also a state root. So we kind of propose both to be like, hey, this transaction produced this state, and this is why this is the current state of rollups. As a user, all you're seeing is the rollup kind of functioning as usual, but in the background, we're actually providing a lot of information to L1 Ethereum to be able to leverage its security later on. And then this continues to happen. You do more transactions, you roll up more state, and we are constantly submitting back into Ethereum to make sure that like both are in sync, that you can use Ethereum's information to see what's going on Optimism. But what happens when there's a faulty transaction? In this case, TX2 on the graph, let's say something is but let's say this is an attacker who produced this block. So I guess let's go back a bit into the rollup architecture. So in this case, the state is kept by the sequencer, and how rollups decentralize is that anyone can become the sequencer to produce blocks. But the sequencer must submit back to L1, and sequencer election happens in a combination between L1 and L2. So the sequencer can technically be anyone. And how is that secure? It is secured by what I'm going to talk about. So in this case, if we have a false, say a bad transaction, this is most likely caused by a bad sequencer, because anyone can be the sequencer. But now in the next step, you'll kind of see why not everyone would want to be the sequencer in this world. So let's say a bad transaction happens, and then we have this faulted state. What we will do in L1 is that we will call a contract that is part of our L1 contract to prove fraud, where we re-execute this transaction to be like, hey, in the perfect, in the actual scenario of this rollup, it actually should provide this other state transition instead. So what happened here is likely say, you send your friend Bob 20 ETH, but you as an attacker say that the 20 ETH actually does nothing to diminish your balance. In that case, that's just untrue. So we call this proof fraud mechanism on L1 to kind of enforce what the truth is. And in this case, kind of tell L2 what the actual state is. So this is why this is how L2 uses L1 security.
There's a question that's just popped into the chat box. One is, what does finality look like? What is finality like?
So finality on rollups is really in two forms. So there's finality when it is confirmed on the sequencer, and then there's finality when it is submitted to L1. So the submitted to L1 finality is what I think people typically use, because in this current DApp scenario, a lot of people run their own verifiers, and verifiers are the ones that can see when fraud faults happen and then call proof faults on L1 to enforce this truth. So most people use L1 finality, and that takes about 5 to 10 minutes. And then so that's for the finality question. And so is it possible to not wait for a transaction to roll up? So actually a lot of people just wait for sequencer confirmation as part of the DApp experience, or they wait for kind of, they just trust the sequencer because they're running verifiers. We're, I think, going to see some industry standards change, because right now the sequencer operator is OP Lab, which is the company that contributes to Optimism, and also where I work. So currently, I think there's a lot of sequencer trust, but we're going to see that kind of like shift differently as the rollup gradually decentralizes. We have a TX pool, but I think the attack vector is, let's see, I think there will be attack vectors in the future with sequencer swapping. So that's someplace that it has to be a very phased rollout. But I think in the future, it is, let me think about this, like a sequencer produces, I think whatever is the sequencer state, we assume that it is going to be submitted to L1, or people will kind of be unable to continue syncing the chain if you're syncing from L1. So the attack vector is less meaningful if we kind of establish finality as L1 Ethereum. So that might be like a good industry standard to adhere to if there's a low trust sequencer environment. So kind of going forward saying, okay, like this attack vector exists if people don't use L1. So look at your question, elaboration, microtransaction speed, not have to wait for the next block on L1 each time. Yeah, I think this depends on how closely you want to run your verifier. So for our verifiers, we have those that sync from both L1 and L2. So if you want to do that, and you sync from L2, then you just want to have your verifier be able to re-execute the transaction. And if it establishes the same result, then you can kind of continue trusting it instead of have this nonce manipulation step. Does that make sense? I know that was a lot of new information too. Let's see. The next question is, how is composability like in the rollup? So we have a general computation rollup. So the composability is anything that's deployed to the rollup that's equivalent to Ethereum. So on Optimism today, you can kind of call Aave or like Uniswap as it like composably, since everything is deployed to the same state. But as we see people start deploying rollup app chains, composability will look different. But we kind of have Optimism is working on this fun new prototyping idea of potentially having composability across OP chains. That's going to be more far out, but that's a little bit of tiny alpha in the future. Next question, is there a scenario in which there's a mismatch between finality on L1 and L2? So not for the submitted L1 state, but there is this head that is different. And I think the only time that there's a mismatch is if there's like a faults that happen in the unsubmitted transaction, then there would be a difference. So the mismatch is actually like going to be like when something bad happens. And so in most cases, there shouldn't be, except for like the time period that there is transactions that hasn't been submitted and that's expected. So there's a bad case and a good case. And the good case is just unsubmitted transactions, and the bad case is if someone is trying to attack the rollup. How long is the finality on OP-RAM sequencer? We tend to submit to L1, I think on an average of between 3 to 4 minutes. I need to check on that. But the worst, I think, submission time we do is like under 10 minutes. So that's for L1. But we're seeing people use sequencer finality when they run verifiers since they sync with L2, but they also execute transactions locally to kind of check what's happening on L2 is also happening correctly. Yeah, those are great questions. How quick can MetaMask return from submitting a transaction? MetaMask can return pretty quickly. So I think if you were even using a node provider like Alchemy and Infura, they're actually running verifiers that sync directly to L2. So if your verifier doesn't pause, if their verifier doesn't pause, then yeah, you're kind of like, it's the same trust model of that their node is doing the safety checks for you, in which we ask them to do. So I think MetaMask you can submit like as frequently as Ethereum. Yeah, you can get sub-second transactions. Yep. Yeah, I think the UX of rollups is actually very similar to the UX of Ethereum because, and the only difference is that instead of nodes staying in sync, is the verifier staying in sync and needing to do this extra step for this fault mechanism. So under the hood, there's all this stuff going on, but actually on top of it, the UX is very similar. And if something goes wrong, it'll be kind of like a similar thing where the nodes do a chain split. And in this case, the verifiers will stop syncing and submit faults. So the actual day-to-day UX is actually, you can use it just like Ethereum instead of need to think about all of these things under the hood, unless you are, I think, developing an app that kind of, for high security apps, they run their own verifiers and kind of do this trust model. And for lower security apps, or like just doing a prototype, and you can kind of use it the same way as Ethereum before you put in huge amounts of money on it. Cool. Yeah, these are great questions. I'll keep an eye on the chat and like try to pause when y'all have new things you want to ask. Yeah, so in this case, so going back to this, when there is fault, and to like be clear, I think the assumption is that we want it such that fault proofs don't happen very much because it's economically not not smart to do so. So when we see this, we have L1 to kind of correct these transactions that have incorrect state transitions. So kind of re-explaining that concept, but in words, the fault proof happens on L1 essentially by rerunning the L2 transaction on L1. I've once made this joke that, oh, there are some blockchains that are Go block, like the clients are written in Go, some of the clients are written in Rust. But the really fun thing about rollups is that one client always has to be written in Solidity or something that can be run on the EVM, because the L1 is really your other client that makes, and like the fair, trustless client. So that's a really fun insight. So the way Optimism approaches the fault proof, we have a prototype called Canon, where we have a Go EVM. So this is like a Solidity contract that writes get compiled to MIPS, which can run on chain. Let me see if I can show you this link here. And click out. So this is, yeah, our like fault proof repository. If you look at kind of like the languages here, yeah, it's a lot of Solidity because all of these get deployed as contracts on chain. I actually don't know what the assembly ones are part of. And Go, some of this is an implementation of this thing called mini get, where we do a very small version of get that we can put on chain. But we basically, the idea of this, yet switching back, is that we deploy get onto Ethereum and have it kind of check our work in the client, which is the one that's producing blocks. And to go deep dive into this one file, also going deeper, so MIPS is actually like a machine code language where if you think about, it's like one level above assembly in terms of like what languages gets compiled to. So it's like a very simple VM here where we implemented like basically MIPS, a mixed contract, where you're doing like really, really low level things, but on the EVM itself. Very cool. I'll try to link, actually, I'll throw a link of this in the comments if people want to look at it. This is the MIPS contract. In chat. Now it's in chat. And I will go back to my original presentation. Yeah, so that is the vault proof that we're going to start productionizing early next year when we have a new systems upgrade. But actually, that's not how Optimism has always worked, because another approach we scoped is writing Solidity that executes transactions the way exactly that Geth does. So what this is different is that we basically just wrote something that executed a transaction in one step and checks its work. So it's like a lighter wrapper instead of something that executes like the whole Geth client. You just kind of do like a transaction executor. All of these are very minute details, but I'm just trying to go over how like even those really small details make a huge difference in how you deploy things on chain. Like in the past, we had one contract that was just like, I think the execution manager, where it just like does that single step transaction. And since then we have like kind of broken it down to like doing smaller transactions and finding where exactly things went wrong if there is fault on the rollup. Cool. So that is kind of how the speed run of how fault proofs work. The second part here, I think narratives has changed a lot since, so I'll try to give like a little bit of tidbit of what's going on. But at first, there was the question of, are Rollups still relevant after ETH is staking, after ETH has sharding? So kind of the common, like lesser known, maybe now getting more well-known fact is that Ethereum is going to use rollups to scale in the medium and possibly even long term. That rollups will become kind of these shards and when we say medium to long term, I mean like in the next 10 years, we're certain that rollups will like play a role in scaling. And after the next 10 years, I think rollups would have gone to a point where it's either architecturally similar to how we want to do sharding or like already parallel. Is there a guide to deploying on Bedrock on Girly? Yes, we do have a guide. And let me find this for you, bedrock.optimism.io. We have an alpha testnet and we're going to have a beta one first too. So if you want to keep track of this link, this one will be updated in sync with the different testnets that are rolling out. So there is a guide there and you can use this, but this is very rough. Like I don't even think there's no bridge front end for this, but there is an easy way to get funds on there. Sample TX and Ethereum from Optimism. Cool, let's see. The easiest way to get this is through Etherscan, where if you want to look at L1 to L2, these are the L1 to L2 transactions. So these are deposits, and these are the latest L1 batches. So let's see, if we look at this batch, this links to an L1 transaction hash. So this is an example transaction. And that flow is how you find it. Oh, so let me go back to question. Deploy Bedrock on Girly. You want to deploy a testnet itself, right? Is that the question? Okay. So that one would be, let's see, Optimism. I think the easiest way to do that would be, let me see. I think this might be the easiest way to start, but we have a lot of conflicting documentation here. So let's see. I would say start here. No, not there. Bedrock.net. And see how far you can go. I will say that DevX is a little clunky with how, especially with deploying a testnet, because that's something that we are like trying to not yet productionizing as we upgrade our system, but but it's all in this repo. If you can piece it together, feel free to like make a contribution to like getting all the random docs together. But definitely just dig in our mono repo and kind of prep for all the repos starting, like all the sub repositories starting with Bedrock. Cool. Yeah, I'm excited to see what you build. I think if you can pass through the bad documentation here, then you can really do anything. Like the teams that have deployed Bedrock by themselves have all built amazing products. In this way, we're kind of seeing the feature as the bug. But anyway, coming back to Rollups and Ethereum scaling. So if you haven't seen this post, this has been a while ago, but this is really the defining post of like what spurred off all the rollups, Optimism, Arbitrum, Fuel, like all of them kind of started off, or like start of these organizations really, I think, made the ETH core dev team as well as Vitalik realize that this is the way to scale Ethereum. And ETH1 has pivoted some of its efforts to being more friendly towards rollups. I'll go over into like the ongoing efforts today. Like 1559 is something like, even though it's something that everyone benefited from, it's also something that rollups benefited from. And yeah, repurpose clients, that's something that like everyone is kind of doing using Geth. Optimism is like certainly following this approach of making reusing L1 clients. So yeah, a lot of these things are already happening. So if you ever feel like some light reading, this is a very cool post to kind of see the history of rollups. But some of the implications of this is that Ethereum is focusing on being a data availability layer that has like really robust consensus instead of like truly advancing on-chain computation in the layers of sharding. That will still be something that's necessary, as we will need execution shards to see how fault proofs or fraud proofs happen. But right now in the middle term, medium, long term, we're seeing Ethereum kind of work with rollups to scale. Yeah, so what about decentralization in this case? So kind of going back from the previous part. So in a rollup, block production is centralized. We have this entity called the sequencer that produces blocks. But block validation is trustless and highly decentralized, which are the verifiers, kind of the equivalent of nodes on L1. And for censorship resistance, we have an L1 contract that lets the sequencer forcibly include transactions. So that's something that is enforced, but we're constantly thinking of better ways for censorship resistance to be as fast as, say, talking directly to the sequencer. How can block production be decentralized? So I would say on a grander scheme, block production will be decentralized in that the sequencer will be swapped in and out. But if we look at one point in time, it will always be one sequencer producing blocks. Does that make sense? So it's decentralized in the sense that we want to make it so that anyone can be the sequencer, but it will always be one sequencer producing blocks. Which I guess it's always one validator producing the current block too. Before the sequencer, it'll likely be a slightly different mechanism than electing validators. Cool. And maybe some of y'all have seen this huge roadmap for Ethereum, but I just wanted to point out that the rollup part is really here in the surge of bringing 100,000 transactions per second to Ethereum. Let me see if I can zoom in. Actually, it doesn't let me zoom in. But I plucked this from Vitalik's Twitter, and you can kind of follow along to see where everything is going. And I think everything in the end will kind of benefit rollups, or especially rollups that are very close to Ethereum. So Optimism is Ethereum equivalent. So we actually reuse a lot of Ethereum's code. So everything down here will actually help us too, because we'll have a cleaner client and cleaner architecture to work with. EIP 4844 is the main Ethereum improvement that would really help rollups. You can go on this website. It has a ton of information and all the links to how work is being done today there. And kind of the big premise today is that rollups are cheap, but not billions of users cheap. If you have been on L2 fees, you'll see that it's still about like 5 cents, sometimes like between 2 to 5 cents to send transactions on a rollup and kind of do like a swap. Whereas on a side chain, it can be less than a cent, just due to different gas limits and congestion mechanism, but compared to different L1 chains. But for the L2 compared to side chains argument is that it's still very expensive to submit data back to Ethereum for the security cost, because every time a rollup submits rolls up transactions to Ethereum, it's this huge transaction blob, and that usually costs a lot. That's a lot of the security costs. That's a lot of the cost out of a rollup. So 4844 diminishes that cost by introducing transactions, this transaction type that posts blobs to the beacon chain. So instead of storing it permanently in state, which is expensive, it posts like a different type of transaction that has like a blob associated with it that's purely rolled up transactions. And rollups then only post state roots to Ethereum state, which saves a lot of money. What size can include transaction data? I think transaction data go all the way up to, so let me actually go here because I was reading about it yesterday and I don't want to give you kind of bad numbers, but right here in the FAQ, I think there's a debate on how big can this really be. So yeah, I think 1 megabyte data to blobs, yes. So the average load is about 90 kilobytes. But if it's the maximum block size is about 1.8 megabytes. Yeah. So if we do this, an average block size would get pretty big, and we have a potential to have 18 megabyte blocks. And as we know, state growth is a huge problem. So that will like greatly constrain who can run nodes. So I think right now between 90 kilobytes to 1 megabyte, 2 megabytes is the average load. Cool. So I kind of quickly breezed through everything, and I wanted to, open to running it back or going deeper into anything that I talked about. But 4844 is kind of the new thing, and this website, even like it has a lot of resources in terms of what's been going on, like the discussions that's been happening and how it works. Definitely follow through if you're interested in seeing rollups become super cheap. What is the average transaction cost at the moment? The best way to check this is l2fees.info. And we are probably pretty congested right now. Yesterday when I checked, it was, I think, 3 cents for a send and 5 cents for a swap token. I think this fluctuates. I wonder if there is a graph. I think internally we have a graph, but I think this is anywhere from like 3 to 10 cents, and this one probably a little bit more. But with our Bedrock upgrade that's coming in January, I think this gets it to, I think, about like between half to 3/4 of the current cost, because all the optimizations we did. Is cost going to drop later? Because if OP goes 10x, it'll cost 70 cents. Do you mean the token? Because actually OP is not the gas token. So this is in Ethereum. Yeah, so OP token isn't a gas token, but it one day may become a sequencer auction token in which the economics wouldn't really be the on-chain the on-chain congestion, but rather like the competition to be a sequencer. IP4844. Is anyone, I'm wondering for the person who's deploying an Optimism chain or anyone who is deploying a rollup, what are y'all building? The Optimism Game Boy, so that is one of the most exciting things, but it is in stealth right now. So I don't have a public access to the repo. I don't believe anyone does. Yeah. Validium rollup is a fun idea. Yeah, I'm very excited to see that. Hopefully the documentation works for you. Generate quickly, but patent GPU heavy. Ooh, that's very fun. Drone monitor. Yeah, I'm assuming a drone monitor needs very fast updates, so you'll need a cheap transactions, I'm guessing. NFTs on L1 representing NFTs on L2. With that one, let me make a recommendation of this thing, which is what this is what ENS is working on in terms of L1, L2 connections. I think they're in the process of implementing this, but this is really interesting for potentially L1 represent an L2 like interoperable NFTs. So this will be pretty fun. Is there a way to get in touch with me? Yeah, I think let's use an official encode. Do we have a Discord that I should join, Alex?
Yeah, so we've got a Discord forum on the Metaverse Discord channel for Optimism. So I can just add you to that, and from there, everyone can just ask you the question. So whoever has questions specifically for Optimism, you can ask your questions in that forum. Annie will be there, and we can get other people from Optimism to join as well if there are too many questions to be answered. But yeah, any other questions we can try assist with too. We've got another question. Any specific thing to keep in mind before deploying contracts, such as size and standard?
Yeah. So I think for deploying contracts, there is not a size limit, or there's the same size limit as Ethereum. So anything that is an L1 contract would work on L2. So we're keeping, I think, the same standard here. And for if you're doing gas optimizations, I think for L2, even though it's already really cheap, if you want to like get it absolutely like the best with the bang for your buck, then I think optimizing for as little call data as possible is probably the best way to go, depending on how cheap you want to make your app. But I think for a hackathon, maybe the best thing is working on the most compelling product. So divide your time wisely.
Thans, Annie. Thanks for asking that, Michelle. Continue.
Yeah. And I see people asking for a faucet, and I think the one that I recommend is, let me check the paradigm faucet. Actually, there's Optimism faucet.xyz, I think. The Bedrock faucet, if you look at bedrock.optimism.io, there is a way for you to receive funds. I think you may need to have Girly ETH. Best DeFi projects to build on top of. I think beyond the typical kind of Uniswap, like L1 projects, so the synthetics community is huge on Optimism. And we've seen a lot of people like in their ecosystem thrive around like Thales and Aelin and such. So that's always like a thriving ecosystem. And Velodrome, this DEX that's based on kind of Andre's idea of like solidly around emissions is also doing really well on Optimism. So those are top of mind for me. But I think our DeFi team would have stronger opinions. For pointing Brownie at Optimism, I think you do need to change your chain ID and like chain configuration. So it's a little more than the RPC, but if you go to chain list, that should have everything you need. You don't have to do any deeper configuration than I believe chain ID and native currency. Yeah, but besides that, you don't really need to change anything else.
All right, Annie, thank you so much for coming. It was awesome having you here. I hope you all enjoyed it. I hope you all got your questions in. If you do have any more questions for Annie, we'll get her onto the Discord channel, onto the Optimism forum questions, and you can ask all your questions there. We've got 5 more days to hack until final submission. Final submission is midnight, your time zone, on Sunday, the 4th of December. So I hope you guys are already hacking away, and we're really excited to see all the projects. Hope you have a lovely day or evening wherever you are in the world. Annie, again, thank you so much for your time. We really appreciated it.
Yeah, thank you. Thank you for running this workshop flawlessly, Alex.
Awesome. Have a good day, everyone.